Hello sir, I'm Ray. Now I'd like to start explaining the code for assignment 2. This is the dataset after pre-processing in assignment 1, and it's what I used for assignment 2. The first step is to add a new column called shipping delay. Right here. It is calculated by subtracting all the data from shipping date, which gives me the time it takes to ship an order. Based on the analysis from assignment 1, I found that shipping delay is one of the features that can affect profit. And the next is feature selection. Based on the initial analysis in assignment 1, I identified which columns are related to profit and which are not. So here I remove all the unrelated columns and keep only the relevant ones. This is done using this code. I keep those columns named segment, category, region, discount, quantity, sales, profit margin, shipping delay, and profit. Okay. And then is recording the text columns. I convert the relevant columns such as segment, category, and regions into one hot encode. This allows me to use them in machine learning models for prediction. This is done using like this code. Okay. And after completing all the steps, I got a clean dataset like this. And I also check the data types of each columns to make sure everything is in numerical format, because all the things is in the red format, which is suitable for machine learning algorithms. And next, I made 4 copies of the datasets: 1, 2, 3, and 4. These are used for training and tuning 2 different machine learning models, and for making predictions with each of them. And in this assignment, I used 2 algorithms, random forest and XGBoost. And in the XGBoost part, I first split the dataset 80% for training side and for training, and 20% for testing. Then I create a pipeline. This is a pipeline that include the scalar and the regressor named XGBoost regressor. Next, instead of using the default hyperparameters, I selected several key ones to tune. Here you can see the range of values I used for optimization. And to search for the best combinations, I used the randomized search CV. And I also wrote a loop. This is the loop structure. I wrote a loop to log each hyperparameter combination along with its evaluation metrics, such as MSE, R-squared, Pearson, and Spearman. So I could check the performance of each model during the tuning process. And in the end, I create a table that looks like this. It looks like a log, optimization log. It contains each hyperparameter each hyperparameter combinations, along with its evaluation metrics. And the evaluation scores is right here. MSE, R-squared, Pearson, and Spearman. And there is also a column called is best that shows whether the combinations is the best or not. You can see the false, that means it's not the best. And the true, there is a true here is only one true. That means this is the best combinations. So we can use this hyperparameter combination, the number 19, to deploy them into the next step. And for random forest model, I followed the same process, splitting the dataset, defining the pipeline, tuning the hyperparameters using the random search CV, and logging the results. Just use the same method to calculate the MSE, R-squared, Pearson, and Spears, and there is also a column's name is best to show it's the best or not. And finally, we can get the same tables like this. And they can tell us which one was the best. This one, the number 12, is the best hyperparameter combinations. And next, I used the best hyperparameter combinations to build a new regressor right here. This one is the best hyperparameter combinations. I follow the same steps as before, like splitting the dataset, define pipeline, training the model and making predictions. Training the model and making the predictions like here, like this. Then I combined the prediction values and the actual values into a single table named datasets, which I used for further evaluation. It's like this. This one is the actual values, and this one is the predicted values. And next, I calculated future importance here. Calculated the future importance for both models using the best hyperparameter. Use the best hyperparameter combinations, and I recorded the importance scores of all features into a table and sorted them in descending orders. Calculate them, use these functions named future importance, and record them as an important data frame. I sorted them in descending orders, and the table is right here. You can see all the feature importance score right here, and the best one is region east, and the second one is perfect margin. And I do the same method in random forest algorithm. You can see the same table for the prediction results. The actual value, the predicted value is right here, and the analysis. I can get the same tables right here. The same future important the same future importance table right here. And this future importance table clearly shows which features have the most impact on the prediction, which is useful for providing business insights in the next step. And finally, I use this result table to create two visualizations in Power BI. Right here, the left one is for XGBoost and the right one is for Random Forest. This chart clearly shows the prediction results and help with performance evaluations. That's all from me. Thank you for listening.